Uh, so let's talk about the net direction that a reaction will follow when it occurs. All you have to do is compare Q versus KEQ. What happens if Q is less than KEQ? Well, if KEQ is over here, let me do it this way. Let's draw a number line. If KEQ is over here and Q is over here, okay, what will happen? The reaction will have to occur so that eventually Q becomes equal to KEQ, right? So Q will have to increase until it becomes equal to KEQ. Because if Q decreases, it cannot be equal to KEQ if it's less than KEQ, right? How can Q increase? How do you calculate Q? Something that depends on the products over something that depends on the reactants, right? How can you increase Q? You make more products, right? So you need to shift to the right. So we say there will be a net forward reaction until Q becomes equal to KEQ. So this is an easy way to remember it. If Q is less than KEQ, the reaction is going to shift forward, going to go forward until Q becomes equal to KEQ. Okay? So the forward reaction makes Q larger because that's going to give you more products. So your numerator is going to increase. What happens if Q is larger than KEQ? If Q is over here? Then we say there will be a net reverse reaction. Okay, the reverse reaction will predominate until Q becomes equal to KQ, and you have reached your equilibrium. Okay, so let's do a few clicker questions. We have A going to B. 1 mole of A gives you 2 moles of B in aqueous solution. KEQ is 10. Which way will the net reaction occur in a mixture where if Q happens to be 0.1? Is it going to go forward, reverse, or neither? If Q is less than KEQ, it goes forward. Okay? Again, here's your KEQ. If Q is less than KEQ, it goes forward. Okay? Here. Slightly more complicated. Same reaction, same KEQ. Which way will the net reaction occur if for this particular reaction mixture you have a concentration of 0.1 for A and there is no B? Will the reaction go forward, reverse, or neither? Oh. What's our Q? How do you calculate Q? Products over reactants. What's our product? B, right? What do you do to B? Squared, and a reactant? A. So what's the concentration of B right now? 0. 0 squared over 0.100 is... So how does Q compare to KEQ? KEQ is 10. Where is Q? Where is 0? Q is 0. So which way will it go? Forward. Okay. Next question. This time, think of it this way. You don't have any B. The only way for the reaction to go is forward, right? You can't go reverse. There's no way, there's no B that you can use out. Okay, let's look at this one. Which way will the net reaction occur in a mixture where A is 0 and B is 0.1? Is it going to go forward, reverse, or neither? Ooh. Q would be equal to B over A, right? So it's B squared over A. So it's 0.100 over 0. Divide by a smaller number, you make Q very big, right? In fact, this approaches infinity. So the only way for the reaction to go is to the left. If Q is very large, okay, over here at infinity, and KEQ is down here at 10. Okay, so correct answer is reverse. Let's try this one. A is 0.1, B is 0.1, same reaction, same KEQ. Will it go forward or reverse? Or is it at equilibrium already? Most say forward. Let's see. Q equals concentration of products over reactants. What's our product? B, and then you square it over A. And so what's our Q in this case? 0.1 squared divided by A, which is 0.1. What is 0.1 squared over 0.1? 0.1. Is that less than, greater than, or equal to KEQ? Less than 10.0, which is our KEQ. So reaction will go forward. Finally.